Assalamualaikum dan salam sejahtera. My name is Ammar bin Muhammad Johan from class 4 Al-Ammar. Today I'm going to explain about arithmetic progression. So let's start. The basics. First, the difference between any two consecutive terms of a sequence is a fixed constant. The constant is known as common differences and is represented by D. Remember that D is the letter that represents common differences. Common differences formula, that is D equals T2 minus T1. Remember that T2 always comes first, then it's followed by T1. If it must be the biggest number minus the small one. That is T2 minus T1 equals also T3 minus T2 because it's fixed and common. So the answer must be the same. So let's start by doing a simple question. An auditorium has 15 chairs in the first row, 19 chairs in the second row, 23 chairs in the third row, and so on and so forth. Determine whether the arrangement of chairs in each row follows an arithmetic progression. Give your justification. So we must see first, look at the numbers given, that is 15. As you can tell, it progresses upward. That is 15, then followed by 19 and 23. So there must be a difference. Determine whether the arrangement of chairs in each row follows an arithmetic progression. Okay, let's see. Let's solve it. Okay, first determine the sequence, that is 15, then followed by 19, then 23, and so on and so forth. Then we use the formula, that is D equals to T2 minus T1. So we have D minus T2, that is the second row, 19 minus the first row, 15, equals to 4. Then we use it second. D2 equals to T3, that is 23, minus T2, that is 19. The answer is also 4. So you can tell that the answer is same because it is fixed constant. If it's not fixed, then it's not a common difference. So we answer the question, then the answer is yes, it is arithmetic progression. Okay, the nth term of an arithmetic progression can be written as T n equals to A, that is the first number, plus n, the number, minus 1 times D, that is common differences. Okay, let's solve a question. In a book fair, Siti wants to arrange books at the front section. She arranges books by stacking them with the first book at 2 cm thickness at the bottom. However, the subsequent books have the same thickness, which is 1.5. Okay, the question already given the first number, A, that is 2. And then here it says subsequence. So the common difference is 1.5. Okay. Find the total thickness of the books if Siti arranged 16 books. B, the number of books if the height of the books is 30.5 centimeters. Let's solve it. First, we determine the sequence. First number, that is 2, the bottom row, then plus 1.5, 3, 0.5 plus 1.5 equal 5, and so on and so forth. So we already know that the A is 2 and the common difference is 1.5. And then we use the formula. We want to know the row, that is T n equals A plus n minus 1 times D. So the A is 20, A is 2 plus 16, the 16 row. You want to know what the thickness of the 16 row, that is n minus 1 times 1.5, then you will get the answer, that is 16 row is 24.5 centimeters. Okay, let's answer the next one. So the B, the thickness of the n row is 30.5. So we use the formula, that is Tn. We already know that 30.5. We put 30.5 equals to 2 plus n, the number of row, which we don't know, we want to solve it, minus 1 times 1.5. We convert there, we just change the position, then we will get the n minus 1 equals to 19. Then we put 1 over there, then we got 19 plus 1, then the n is 20, that is the 20 row. 30.5 thickness is at the 20th row. Okay, hope you understand now. Move on. The formula for the sum of the n. Okay, this is the sum of the n term is Sn. That means from the first row until that row combined is the S. So the formula is Sn equals to n over 2 times A plus T n, or Sn equals to n over 2 A plus 1. Okay, the n term can be obtained using the formula Tn equals to Sn minus Sn minus 1. Okay, you want to know the nth term. Okay, let's solve a question. A swarm of bees started to make a new beehive. 2 hexagonal holes were made on the first day. First day 2. Then 5 hexagonal holes were made on that day, and 8 on the followed until the beehive is ready. Calculate the number of hexagonal holes on the 12th day. Okay, first question, it wants the number of hexagonal holes on the 12th day. Then the second question wants the minimum number of days if there are more than 1000 hexagonal holes made. Let's solve it. Solution first. Determine the sequence of the number of hexagonals, that is 2 and then 5 and then 8 and so on and so forth. Use the formula, that is Sn. N is 12 on the 12th day, number that is 12. Then n, that is 12 over 2 bracket 2 times A, that is 2, plus 12 minus 1, and then the common difference D, that is 3. And then the answer, when you solve it, you will get 222 on the 12th day. Okay, next, for B, use the formula, the total number of say n, Sn. Sn over 1000, right? So Sn must be over 1000. Then we convert that is n over 2 equals to 2a plus n minus 1 times common difference, because Sn is equal to this, so we just convert it, and it will equal over, will be more greater than 1000. So then we insert the number that is n, we don't know, is over 2 times 2 times 2 times a, that is 2, plus n minus 1 times d, that is 3, then over 1000. Then we do a simple math. Okay, then we solve it. N in bracket 1 minus 3n over 2000. We move the 2's over there, so we get 2000. We get 3n times 3n power of 2 plus n, because we times the n outside. Okay, and then we get 3n squared plus n minus 2000. We move this to here, then when we put it in the calculator, we will get n now is greater than 25.65. Thus the answer of 4b is 26 days to get over 1000. Okay, hope you understand what I'm trying to say. That is all. Thank you for your time.